Hello everyone, welcome to ShopDev. So in this video we are going to have a look at a very special subject, the Lambda expressions in C#. Okay, so these Lambda expressions are commonly used when we're making use of link expressions. So let's start by a classic introduction. Okay, so basically Lambda expressions are mainly used with delegates and they are invoked via delegates, and they can be used instead of anonymous methods. Okay, so you have a special syntax for that. You have instead of using a method, you can make use of these Lambda expressions, and the special syntax is that you specify the parameter list followed by the Lambda operator and your statements or statement body. Okay, you can also have a statement block, but when you have a statement block, so you need to specify braces. Okay, so we'll see that in a later slide. Okay, and a Lambda expression can be converted to a delegate type. Okay, so if Lambda expressions return a value, it can be converted to a Func delegate, or if it returns no value, it can be converted to an action delegate. Okay, so consider this simple example where you have a Func delegate that takes as input parameter an integer and returns an integer, and the operation is squaring a number. Okay, so delegates, we have three ways of implementing them. First, you define a square number method, okay, that has an integer return type, a parameter of type int, performs the squaring of the numbers and returns the value. Okay, so see the next line. So when this delegate is invoked, internally it points to this function. This function is called and returns the results here. Okay, in the square number variable. And 3 1 squared, we get the value 9. Okay, a second way of implementing the delegate body is by making use of anonymous methods. Okay, so you have a delegate keyword, you specify your input parameter, use braces, and the return type where you scale the numbers. At the next line, where the delegate is invoked, it internally calls the function that is pointing to, it squares the numbers and returns the value. Now with Lambda expressions, you can avoid defining first of all a custom method or anonymous methods. Okay, so to do that, you specify your input parameters. Okay, if you have only one parameter, like I said, the round brackets are optional. You specify the Lambda operator and what should be inside the method body. Okay, so you square the number here, and at the next line, when the delegate is invoked, it will call this piece of code, will get executed, and the value is returned. Notice that here with Lambda expressions, I haven't specified first the parameter type as compared to anonymous methods or in methods, and I haven't made use of the return keyword. Okay, but still I can make use of the func delegate, okay, to invoke this. So this is because the compiler infers the parameter input via the delegate and the return type also via the delegate. Okay, so let's have a look one by one each of these three scenarios and whether it gives us the same result. Okay, so let's begin by specifying my delegate, my func delegate. Okay, oh, sorry, should be defined inside the class. Okay, so this is an example of delegate definition. Okay, so it's accepted as input an integer and returns an integer. Okay, Next, I will define a method. Okay, let's put it here. So I have a method, square number method, that accepts as input an integer and returns an integer. And inside, I'm just squaring the number. Okay, now I will just implement. Okay, and what I'm doing here, I'm making my delegate pointing to this same number method. Okay, and at this line, okay, the delegate will be invoked and executing this method and displaying the number on the console. Okay, just putting a read line to block the execution. So let's analyze. Okay, so see here, the delegate is not invoked. Okay, this is the line it will be invoked, and it squares the number, and 9 is my value is 9. Okay, and 9 is displayed on the screen. Okay, so that's the classic way with delegates. Now let's have a look of anonymous methods. Okay, I no longer need that. With anonymous methods, how it works. Okay, so here I have my implementation with anonymous methods. So my delegate will be pointing to this anonymous method. Okay, so here, like you can see, I have my return keyword inside my body and the parameter type. Okay, so it matches the signature of the func delegate. Okay, so logically, what's inside the body will be executed when I execute this line. Okay, okay, so assigning anonymous method to my delegate, calling the square number. Okay, see the breakpoint is hit here. Okay, when I invoke the delegate to obtain the results, it computes the number and returns the result, and my number is 9. Okay, like my previous implementation. So 9 is displayed again on the screen. Okay, so that's for the anonymous method. And now, instead of using anonymous method, we'll just make use of a lambda expression. Okay, like we saw previously. Okay, so my delegate will be pointing to my lambda expression. So this defines the input parameter separated by the lambda operator and the processing. So I just put a breakpoint just to analyze. Okay, so executing, and here my delegate will be invoked. So let's see. Okay, so execution flows from here to here. My numbers are squared and I obtain the results, and the number is 9. Okay, so hope you understood it, that part, the basics. So see, number 9 is printed on the screen. Okay, so that was a basic introduction of delegates, lambda expressions. And now let's go deeper to look at the syntax and variations of the lambda expressions. So we have two variations of lambda expressions. So first we have the expression lambda. So it has just a expression and its body. Okay, so like we saw, like in a simple example, squaring a number. Okay, so you have your parameter list and a basic expression, okay, to perform your operation. Next, you have a statement lambda. Okay, so you have an input parameter list and a sequence of statement. So this, for example, is an example of a statement lambda. Okay, you have several operations. So here, for example, I have an action delegate that doesn't return a value but accepts an input. Okay, and inside that input, I'm printing that message into the console using the green foreground color. Okay, so we already had a look at this one, but we just have a look at the statement lambda. Okay, so let me open my Visual Studio. I no longer need that. So I just have my example, an action delegate. Okay, I just put a breakpoint inside. And let's see when that is invoked. Okay. Okay. Now step into. Okay, so you see here my hello world message is being displayed on the screen with a green foreground color. Okay, so that was for expression lambdas and lambda statement. Okay, so we already had a look at these concepts. Next, we're going to have a look at the parameters, okay, in detail. Okay, so like I said, when you have only one parameter, okay, so the round brackets are optional, but when you have two or more parameters, okay, or you have zero parameters, you need to specify a round brackets before your expression body. Okay, and sometimes, you know, the compiler cannot infer the types of input parameters, hence you need to specify them explicitly. But see this example, we haven't specified the parameter type, but for this example, well, it is optional, but in case the compiler doesn't infer it, cannot infer it, you need to specify your input parameter types. Okay, and as of C# 9.0, so you can use discard operators, okay, where you can specify two or more input parameters that are not used in the expression, so you can use discard operators instead. Okay, and as of C# 10, the return type of a lambda expression can be specified before the input parameters. Okay, so see this. Okay, so this is a lambda expression. So this part, bool b, where if p is true, it will return 1. Otherwise, if b is false, it will return 2. So here it can return either the value of integer or a string. Okay, and this has been casted to an object type and assigned to a choose declared using the var data type. But with C# 10, okay, what happens is the C# infers the delegate type. Okay, it says that it's it is a Func delegate that accepts a bool as input parameter, this part, and returns an object, okay, which is casted. So this is how you can interpret this piece of code, okay, in C# 10. Okay, sounds good. Okay, so just for the purpose of understanding, let me show you how the compiler can help you when you hover your mouse over the variable. See, it says that it is a Func delegate, okay, that accepts an input. So you can make use of your mouse, and the compiler is quite intelligent, that gives you an indication about the implementation of the Lambda expression. Okay, so hope that this helps you. And before wrapping up, I would like to talk a little more about the operator. Well, this operator, when used in Lambda expressions, is termed as the Lambda operator. But there's an alternative usage of this operator, okay, in the sense that it can also serve as a separator of a member name and the member implementation in an expression body definition. Okay, so what is an expression body definition is that, consider this toString method. So instead of writing a body, you can use this separator. Okay, but this is not a Lambda expression. Okay, and hence you are concatenating the first name and last name. Okay, and trimming it. So this is an alternative of doing this, writing the override toString method and returning the first name and last name, for example. Okay, and trimming it. So remember, when used with delegates, it is many Lambda operator, but when using with a member definition, it is a separator of an expression body definition. Okay, so consider my simple example here. In this case, let me show you. Okay, so this is what I did. So my toString method, okay, and which can be converted this way. Okay, it is the same thing, but an alternative way of writing. So this is called an expression body definition. Okay, using the separator. So that's it, guys. It is important to know the difference, because if you're a newbie to C#, you can get confused and consider this as a Lambda expression, but this is not a Lambda expression. Okay, so to wrap up, just the key points to remember. So Lambda expressions are invoked through the underlying delegate type. Okay, Lambda expression can be used instead of anonymous methods. So we just saw that, with our first example. So we have two variations of Lambda expressions. So we have expression Lambda with only one expression in the body, and statement Lambda when you have several statements. So parentheses are optional for parameters. If only one parameter, well, you don't need to specify it. And parameter types are inferred, or as well as return types. But in case the compiler cannot infer it, then you have to specify the type with Lambda expression. So that's it, guys. So if you like my video, please like it on YouTube and subscribe to my channel. Thank you. Bye.